Hello student, I am welcoming all of you on this Drishti online platform, and today we are going to start with one of the most important thing for the 2026 prelims, and it is the 100 most important topic for geography. And here that 100 most important topic, out of that the first topic it is Earth's interior. In that one we have to discuss about properties of seismic wave of P, S and L wave. Here it is, R wave is also there, but important topic, I am again saying that it is an important topic for 2026 prelims. So we are targeting only important topics, properties of P, S and L seismic wave. Another one, it is in a shadow zone mechanism. In this shadow zone mechanism, there is in a P wave and S wave shadow zone mechanism is there. We have to understand that one, and related some important question we will see also. And thereafter the chemical layers of the earths, and then mechanical layers of earth's interior we have to see. And then earthquake swarm, it is an important in the news from the 2025 onwards. Earthquake swarm is there, and especially this earthquake swarm in California and in Iceland. So that topic and related some course concept and some related question we'll have to see. So let us proceed ahead with the Earth's interior, properties of P wave, S wave and L seismic waves. So first of all we are going to see P wave. P wave, if I am talking about what, it is known as a primary wave, and it is the fastest seismic wave. It is a primary wave. What we can say like it is in a this is in a primary wave. Why it is known as in a primary wave? Because it moves fastest, and it is reaching to any seismic station in the world at the first time initially, for the first. Therefore it is known as a primary wave, and it is in a kind of compressional wave, or you can say that longitudinal wave. Like you can see over here that suppose I said hello, so it started moving ahead. The vibration of the particle is in the direction of the wave, and you can be able to say it is in a kind of what, compressional wave. Here you can also see like compressional wave, and it is in a kind of in which direction of vibration of the particle is in the direction of the wave. That means longitudinal. So here we can say that it is in a longitudinal wave, and here fastest seismic wave. So therefore it reaches to the any seismic. Suppose earthquake occur in India and it is reaching to the any, like USA, European countries, every countries of the world has some seismic station. So these waves, P waves, will reach to that station first. So that is known as a primary wave. And here it is the first to reach seismograph or seismic station in the world, and vibration of the particle are in the direction of the wave. We can say that the vibration of the particle is in the direction of the wave. So here we have been able to see some about P wave, and what is the property of this P wave. So it is in a vibration of the particle is in the direction of the wave, therefore it can pass through solid medium, liquid medium, even in the gaseous medium. But within the Earth's interior, gas medium does not exist. Therefore we can say that P waves can pass through solid as well as liquid. Understood? So it can be the travel through the solids, liquids and gases, but interior of the earth gases does not exist, so we cannot say. But generally longitudinal wave, compressional waves or P waves moves, I said that, through the solid, liquid and gaseous medium. Here velocity increases with depth due to the increasing density. You must have been knowing that in the class 9th and 10th that if the density is higher, the speed or frequency increases. The density is less, the frequency or if speed decreases. In the light chapter you must have read about it. So if within the Earth's interior, if we are going down that the density of the crust, mantle, core, outer core, inner core, density is increasing, where the speed of these seismic waves keep on increasing. But in the case of liquid, speed decreases, solid more, liquid less, gas less. So here we can say that the average speed in the crust is 6 km per second, This is the crust. The upper part of the earth is what? Crust. Here you can say 6 kilometer per second, and thereafter as it enter into this median, this mental part, density increases, therefore the speed becomes 8 to 13 kilometer per second. And core, suddenly in the outer core, if I am talking about, there is an outer core and here it is inner core. In the outer core is in a liquid in nature, so therefore suddenly in the outer core its speed decreases, and suddenly decreases speed in the outer core, and then inner core under very high pressure, it is in a solid, again the speed of the p waves increases. So it is in the inner core increases. What is the importance of that? So what we have seen, the scientists have observed that after the mental depth of the mental is up to 2900 kilometer, and at the depth of the mental onwards, scientists have observed that speed is suddenly decreasing. It means somewhere below 2900 kilometer till 5150 kilometer, outer core is in a water liquid. If the speed decreases, it is not solid, it is in a liquid. Therefore that p waves also help in finding out that outer core is in liquid, because speed is decreasing, and outer core, in the inner core speed is decreasing, it means somewhere it is solid. So p waves help in identifying that it is in an outer core is a liquid, and it also help in understanding some mineral reserves inside the earth crust. If there is somewhere oil reserve is there, the seismic wave speed will decrease in the oil, and in the somewhere other minerals are there, its speed decreases, solid minerals. So somewhere seismic waves also help in identifying minerals below the earth surface. So here we have been able to see about p wave. Another one, S wave. S wave, it is like in a transverse wave. You can say that it is in a transverse wave, or it is also considered as in a secondary wave. Transverse or secondary waves, in which vibration of the particle is perpendicular to the direction of the wave. The direction of the wave is this, but the vibration is taking place perpendicular like this. So here it is in a perpendicular, and then S wave, because of this nature, it can only pass through solid medium, it cannot pass through liquid medium. It cannot pass through liquid, only solid medium, and its speed, because of that, its speed is less also. In comparison to p waves, its speed is less. And if its speed is less, so p waves reaches to the first to the seismic station, it is the fastest, and in the second fastest, it is reaching second to the p wave. Therefore it is known as a secondary wave also, and it is also known as a shear wave or transverse waves. When it is moving like this, it is known as a shear wave, and you know that it is slower than p waves, second to reach the seismograph or seismic station in the world, and the vibration of the particles are perpendicular to the direction of the water wave we have seen. And thereafter here we can say it can travel only through the solid. If this kind of waves are moving, they cannot pass through the liquid, it will only be solid. So it has been found that this S wave, after 2900 kilometer depth, it has been disappeared. It has been observed by the geographer and geoscientist that below 2900 kilometer, it is in a liquid kind of things are there. So travel only through solids, cannot travel through liquids or gases. Particles motion is perpendicular to the direction of the propagation. Its speed, crust may you can be able to see like it is 3.5 and mental 4 to 7 kilometer. Importance, their absence beyond certain angles proves outer core is liquid. So after the 2900 kilometer, it is disappeared, it is not existing. It shows that it is what below there is in a what liquid is there. So this way we have been able to see p waves and S waves. And another one, L wave, this is in a love wave, and it is in a surface wave. P and S waves moves into the interior of the body of the earth. Inside that you have seen like that they are moving inside the body, but the surface, L wave is a surface wave. It moves along the surface of the earth, and it moves side by side and also like a transverse. So because of that, it is the most disastrous. Building will be like this, and the building will be like this also, and then building will collapse. So it is a disastrous wave, surface wave, and we can say that the vibration is taking horizontally from side to side and also moving perpendicular like a transverse to the direction of the wave. It travels along the earth's surface, means nearby the earth's surface it travels, and then the slowest but most destructive, and then we can say responsible for maximum earthquake damage. So this love wave, it is causing, or L wave causing the maximum damage into the earth, onto the earth's surface. Now let us see this question. Consider the following statements regarding seismic wave, and here that P waves is a longitudinal wave and can travel through solids and liquids and gases. Yes, this is the correct statement. Yes, and thereafter we have to see like S waves are the transverse waves and cannot travel through liquids. Yes, it is also, it cannot travel through the liquids, it can only travel through the water solid. This statement is also, you can say, correct. And then L waves travel through the interior of the earth faster than P waves. It is not moving into the interior. Love waves move to the surface of the wave. It is moving along the surface of the earth, not interior of the earth, and it is a very slower. So it is in a what this statement is wrong, and we can say that only 1 and 2 is correct. So this is the question based on the one topic. It is in a P waves, S and L seismic waves. Another important part that we are going to see, it is about it is in a, you can say like so here we are going to see it is about P wave shadow zone, and in the case of P wave shadow zone, and we have to talk about first of all we have to see like here that in this section what we are able to see that from this is the focus of the earthquake. We can say that this is the focus of the earthquake, and in the focus of the earthquake that this is in a P waves are coming out, but these P waves keep on refracting when the one denser medium to another medium moves. So they keep on diffracting. It keep on diffraction, means if any energy is moving from rarer medium to denser, it moves towards the normal, and denser to rarer, it moves away from the normal. You have seen in the class 9th chapter like optics you must have seen. So here again what we are watching like that, in this region there is an, as we are entering into, there is a density differentiation is there. Therefore on the basis of density, you have seen that our seismic waves are coming from here, seismic waves are coming here, keep on diffracting, but in the outer core as it enter, it diffracted. It is able to come to the 103 degree. After that, just slightly at nearby that when enter, it is refracted and enter into the water outer core, and thereafter it is able to come up to 142 degree. So after 103 to 142 degree, P waves are not able to come, and after everywhere you can say that P waves are coming. So P waves are visible everywhere with respect to focus only between 103 degree to 142 degree P wave shadow zone exists, and if any seismic station exists in this region, it cannot be able to detect seismic waves. So we can be able to say that P wave shadow zone, it is located between 103 to 142 degree with respect to what I said that this focus, or I can say that nearby the epicenter of the earth. Causes are sudden drop in velocity at mental and outer core boundary. In the mental and outer core boundary, speed changes, energy changes, therefore refraction take place. What happened? Refraction. So therefore, and refraction due to the liquid outer core and change in density. So because of that, from the 103 degree, it is not able to come 104, 105, 106. It is till 141, it is not able to reach till 142. So between 103 to 142, it cannot be there because outer core is in a liquid and refraction is taking place from the mental and core boundary. And thereafter there is S wave shadow zone we have to see. Already all of you know that S wave cannot enter into the outer core because it is in a liquid. So when it keep on refracting, it is able to reach up to 103 degree. Everywhere it is keep on refracting, able to reach up to 103. So 103 to 180 degree, 103 to 180 degree, it is considered as an S wave shadow zone. So because of that, in this region, S wave cannot reach. So S wave extends between 103 from the epicenter or the focus of the earthquake nearby that. No S waves detected beyond this angle from the 103 degree. After that, S wave cannot be detected by any seismic station, and S waves cannot pass through liquid outer core. Therefore, the reason is this one. Recently, we discussed about the S wave cannot enter into outer core because it is in a liquid, because S waves cannot travel through the liquid medium. Here, let us see some question based on it. Consider the following statement about the shadow zone of seismic waves. The first statement, the shadow zone refers to the areas on the earth where no seismic waves are recorded. That's a correct statement. Another one, S waves create a shadow zone because they cannot travel through the liquid outer core. Yes, sir. It is also creating a shadow zone. Yes. Why? What is the reason? Because outer core is liquid, so it is able to reach up to only 103 degree with respect to epicenter or nearby focus. So S waves create a shadow zone because they cannot travel through the liquid outer core. P waves do not form any shadow zone. P waves form shadow zone between 103 to 142 degree. In some books it is written also 105 to 140. It is a different, but try to understand this is remember it is 103 to 142 degree. So we can be able to say that the third statement is wrong, and then first two statements 1 and 2 is only, we can say that correct. Another topic we are going to say with reference to the earthquake swarms, consider the following statements. So first of all, no, I have to see this question. Chemical layers of the Earth's interior. You know that within the Earth's interior, there is what on the basis of chemical layers. If we have seen many childhood, you must have studied. There is what crust, mantle, and core. Crust is made up of sial. Mantle is made up of what sema, and here it is a core is made up of nickel and ferrous, that is known as a Nife. So that is a chemical layer division, that is known as a chemical layer division. And then crust, if I am talking about the outermost layer of the earth, this is what you can say that it is in a continental crust, and you can say that it is an oceanic crust. In the continental crust, silica and aluminum is maximum. Which one I said that? Silica on the earth's surface where sand, silt, clay you are watching, all these are silica, and after that aluminum. Yes, sir. So therefore with the help of that word comes sial. So what the word comes becomes sial. Sial means silica and aluminum. Continental crust is known as sial. And after that in the ocean crust, which is made up of basaltic rock, and here silicon and magnesium is the highest in the component. So here it is known as a sema. Must remember it is about what? If I am talking about crust, and the crust has been divided into continental crust and oceanic crust. Continental crust is known as a sial. Oceanic crust you can be able to consider it as a sema. Is it okay? So here continental crust thickness you can be able to say that 30 to 70 kilometer. Oceanic crust you can be able to say that 5 to 10 kilometer. In some books it can be written like I said that 25 to 35 or 45 kilometer also. Oceanic crust is written as 5 to 7 kilometer also, or somewhere 7 to 10. But try to take this idea, it will be very helpful for you. That is in a 30 to 70 or oceanic 5 to 10. So here continental crust, if I am talking about, it is mostly silica and aluminum, rich in what? Silicon and aluminum. So therefore sial. And oceanic crust sema, silicon and magnesium, you can say that silicon and magnesium, therefore it is what? Maximum in amount, it is known as what? Sema. So here we can be able to see another point. If I have to talk about the mantle, this is after this one, after this one there is a mantle is there. In the mantle, silicon, magnesium, iron. is higher in component. If we'll take in a container, suppose there is a lighter thing, silica is like a sand, and if we are putting in a magnesium and iron, so if I am shaking this container, so silicon, which is the lighter one, and aluminum is the lightest abundant metal, so it will be on the top, and as heavier things goes down, so in the mantle, silica and magnesium will be, and iron will be in the good amount, and as we go down, the heavier things will be there, nickel and ferrous, these things will be there. So here in the mantle, we can be able to say that silicon, magnesium, and iron is more, and on the basis of that we can be able to say it is known as also SEMA. This is also oceanic crust is SEMA. Here it is a mantle is also considered in a SEMA. And just to know, it is up to the depth of 2890. Somewhere it might be written like 2900 kilometer as well. So no need to worry, both are correct, and it is in a SEMA. And in this one, it is the largest layer, and by volume, 84% of the earth's surface by volume, the mantle is the largest, and core is 16% around, and 0.5% our crust. So here the composition, if I am talking about, dominated by magnesium and iron silicate means silica, magnesium silicate means silica in both, and then important rocks are peridotite and olivine. Must remember, within the mantle there is two rocks are there, peridotite and olivine, and then major components silicon, magnesium and iron. Therefore we can be able to say that this region is known as a SEMA, and the mantle is richer in magnesium and iron silicates. It is okay. In comparison to crust, magnesium and iron is more in the mantle, and thereafter core, innermost layer, that is after 2890 kilometer to 6371, or you can say 6370 kilometer depth, it is in a core is existing on the basis of chemical division I am talking about. So here from the 2890 kilometer to the earth center 637, and here, and we can be able to say like in this region from this 2890 to 6371, or you can say 6370 kilometer, that is also correct. Somewhere it is also written like 6378, even then that is correct. So we can say like here core, if I am talking about that primary iron, it is there more, and nickel, it is known as a Nife. Nothing more than that you need to know. So on the basis of the chemical layers, three layers are there. Yes, crust, mantle and core, and the crust is known as Sial, silica and aluminum is more. In the continental crust Sial, in the oceanic crust SEMA, and in the mantle silicon and magnesium and ferrous is more in the mantle SEMA, and in the core it is, you can be able to say like nickel and ferrous is more. And here the consider the following statement regarding chemical layers of the earth. The earth is chemically divided into crust, mantle, inner core and outer core. No, inner core and outer core is wrong. It is divided into what? Only three layers: crust, mantle and core. It is not inner core, outer core. Inner core is also nickel and ferrous, outer core is also nickel and ferrous. So what is the difference between inner core and outer core? So on the basis of chemical layer, there is an only three division, and that we can be able to say, like I said, that crust, mantle and core. Understood? So if it is talking about inner core and outer core, you have to talk about this is the wrong statement. So on the basis of that, the mantle is mainly composed of silicate minerals rich in magnesium and iron. Yes, that is another silicate materials, magnesium silicate, magnesium iron. So therefore it is in a SEMA, it is considered as. And the core is primarily composed of nickel, ferrous and aluminum. Core is made up of nickel and ferrous, not aluminum. So this statement is wrong. So only the second statement we can say that it is a correct. So we can say that 2 only is correct. The next part that we are going to see mechanical or physical layers of the Earth's interior, and it has been divided into lithosphere, asthenosphere you can be able to say, and thereafter mesosphere, and after that in outer core and inner core. Outer core, inner core is also known as an barysphere at times. So here we are going to see there is in a three divisions, or I said that one, it is in a lithosphere, you can say lithosphere. Another you can say that is in a what, asthenosphere. Another we have to see, yes, mesosphere. And after that there is an outer core and inner core. Yes, this is the division of what, mechanical layers. Mechanical layers means on the basis of the behavior of different Earth's interior, on the basis of the behavior their name has been given. So that is mechanical or physical means what is their behavior. So we can be able to say that this classification is based on the physical properties. What is the behavior? On the basis of how much it is rigid, whether it is a liquid, whether it is solid, and how much it is what, stronger. So on the basis of that there is a mechanical layers is there. And lithosphere, first one we are talking about lithosphere. Lithosphere, if it is said, it is consist of crust and one upper solid mantle. So crust plus upper solid mantle, it is a lithosphere, completely solid. So if somebody is talking about what is lithosphere, it is only crust property is there? No, it has some mantle properties, upper mantle, which is solid part, it is attached. Together they are also known as a plate. When you are studying about plate tectonic, it is also considered as a plate, lithosphere. And this lithosphere is floating over semi-molten asthenosphere. So below this lithosphere till 350 kilometer depth, there is what you can say that semi-molten, yes, asthenosphere exists, over which our tectonic plates, yes, continental plate, oceanic plates are floating, means lithosphere is floating. So here we can say that lithosphere is rigid and brittle. So we are standing on the what, plates, and these are very rigid and very what I said that brittle, it can easily break. It includes crust plus uppermost mantle, means upper solid mantle, and its thickness can varies, yes, 100 kilometers, somewhere 140, 150, where the mountains are formed like Himalayas. Below that there is a lithosphere, depth will be more. So it varies, it is never be the same. And it is broken into tectonic plates, continental plate, oceanic plates. And if you know that there is North American plate, South American plate, Eurasian plate, African plate, Indo-Australian plate, Pacific plate, and very smaller plate like Caribbean plate, Arabian plate, Nazca plate, Juan Dufica plate, different kind of plates are there. It is in a tectonic. So lithosphere has been broken into different plates, major and minor. Now, if I am talking about asthenosphere, it is in a semi-molten and plastic. It is considered as a semi-molten plastic type of layer. It is located just below the lithosphere, and it can be up to the 350 kilometer depth. It allows plate movement, means plates are floating over this. Is it okay? This is an asthenosphere here. Till this, it is in your lithosphere, crust plus upper solid mantle, and this is your asthenosphere. And after that mesosphere. So below 350 kilometer, from 350 kilometer of asthenosphere till 2890 kilometer or 290 kilometer, rest of the lower mantle is known as mesosphere. So here we can be able to see like there is mesosphere is there, and it is in a more rigid due to high pressure, and it extend up to 2900 kilometer, or you can say 2890. This is clear. This is the mesosphere. After that there is a coming of outer core and inner core, and already you know that outer core is in liquid state, responsible for the Earth's magnetic field. So outer core, it is in a magnetic, and in this one iron particles are moving in the way that it creates an Earth's magnetic field. Inside the Earth there is some imaginary large magnetic bars are there, who is creating this Earth magnetic field, and because of this Earth magnetic field around the Earth we have an electromagnetic waves. So who is responsible for that? Outer core. Is it okay? Liquid in nature. And inner core is again in nickel and ferrous. We should not talk about the chemicals, but it is in a very hard, under the pressure it is remain in the solid form, solid due to the immense pressure. So we have talked about, yes, there is a mechanical or physical layers on the basis of their behavior, physical properties, rigidity, strongness, how much brittle, and all this. So we have seen first one, lithosphere. It is highly rigid and brittle it is in nature. So it can be up to the 100 kilometer. Below there is an asthenosphere, and this lithosphere is made up of crust and upper solid mantle. There is an asthenosphere is from 100 to 350 kilometer, and this is what semi-molten plastic in nature. The tectonic plates are moving over it, and thereafter mesosphere, from the asthenosphere finishing point 350 till 2900 kilometer depth, it is in a mesosphere. It is in a very strong and then denser one, and after that there is an outer core. It is in a liquid in nature, which is responsible for formation of what magnetic large magnetic bar inside the earth and magnetic field in our Earth's atmosphere, electromagnetic waves, and our inner core is very solid under the what immense pressure. So now let us see the question. Consider the following statement regarding the mechanical layers of the Earth, that the lithosphere is rigid and it includes the crust and upper solid mantle. That is correct. Uppermost mantle you can say, or upper solid mantle. This is correct one. And then second statement, the asthenosphere is partially molten and allows tectonic plates to what? Move. Yes, it is in a partially or semi-molten you can say, and on this one our plates are moving, and the mesosphere corresponds roughly to the lower mantle. Yes, mesosphere, we can be able to say that mesosphere is the lower part of the mantle. So yes, on the basis of that you can say that 1, 2 and 3 all are, we can say that it is correct. So after that we are going to see about what is earthquake swarms, and especially we have to talk in the what sense of California and Iceland. And generally if I say that earthquake swarms, it is an occurrence of several earthquakes of a small intensity. It is not high intensity. Occurrence of several small earthquakes of several, therefore swarm, lots of, bunch of. But it does not mean that swarms, several small earthquakes comes, thereafter major earthquake will not come. And before the small earthquake, before that there will be also major earthquakes does not come. So swarm earthquake causes, we will see why do the swarm earthquakes in the what California state of USA and in the what Iceland is reason is there. So we'll have to understand, yes, due to some tectonic movement, especially transform boundary, and through the transform boundary some liquids are coming. Yes, liquid make the things little bit, what I said, that lubricants. So when there is an earth transform boundary is there, when the liquid something coming inside it like magma and all, so what it causes, it helps in not giving a strong shock, a strong trembling, a strong shaking of the earth. It will give a small shaking of the earth, small. Yes, very small, and it comes now, ਫਿਰ again comes now. So because in the tectonic region you can be able to say, and in the volcanic region. So let us see, there is a water and it comes at a rapid one, and every earthquake, which is several earthquakes are coming having same magnitude, very small magnitude, but several it is coming, everyone has a similar magnitude. Must remember that what we can say, that it is in a sequence of many small earthquakes occurring in the what limited area, not in large area, in a short period of time without a clear main shocks. There will be no major shocks will be there. Yes, and every earthquake swarm event is having a similar magnitude. It will not be of what very high, very less, something is high, low, and or similar magnitude. And in the what major, we can be able to say the California, and in the what I said that it is in the and Iceland. California is in the United States of America. Let us see again the characteristic, easy manner. It is very much important for your exam point of view. It is a similar magnitude. No dominant main earthquake. Occurs in cluster over days, weeks, or some months. It can come regular. Similar magnitude, small. Usually associated with the tectonic. Yes, tectonic stress, magma movement, or sometimes hydrothermal wind. Three things are there, must remember. Hydrothermal vent, it is along the divergent boundary where the magmas are slowly coming out. So it is in a mouth. Vent means the mouth through which magmas are coming. And sometime hydrothermal, hydro means water and thermal means hot. Hot water comes out. That in this one little bit what shaking is regularly taking place often. So therefore tectonic stress, magma movement and hydrothermal vents often occur near fault zones and volcanic. So these are the things which is already we have been able to see in this region. So causes of earthquake swarms: magma movement, yes. So rising magma underground creates a regular pressure and fractures rocks. So when there is some fractures are there, magma is able to come little bit shaking, little bit shaking, little bit shaking. Always little bit shaking is taking place. Always little bit shaking is taking place. This way you can be able to say that yes, along this what magma movement it happens, like Iceland. Iceland is along the divergent boundary. Fluid pressure in the rocks. Yes, inside the rock some fluid is able to enter. So it is making lubricancy. It is also causing, I say that swarms. Help in what I said, not major earthquake. It helps in the swarm along the faults. Tectonic stress. Yes, along the faults, like in the California state of USA, it is known as the San Andreas fault, which is a transform boundary or strike slip fault, that is known as. In this region, fluid is causing small earthquakes, several. And yes, volcanic activities. And already I have talked about during volcanic eruption, magmas are coming out, little bit shaking, magmas are coming out, little bit shaking, if that will happen. So magma movement, fluid pressure, tectonic stress and volcanic activity it is causing. So with reference to the earthquake swarm, consider the following statement. First one, I said that statement is like earthquake swarms refers to a sequence of many earthquakes occurring in a small area within a short period of time without a single dominant main shock. So there is no, yes, all are several sequence. All the statements, there is a several sequence of small earthquakes are there, similar magnitude. That is a correct statement. Earthquake swarms are commonly associated with the volcanic activity, yes, where the divergent boundary magma is coming out, or hydrothermal vent or tectonic stress, volcanic activity, and geothermal region. Geothermal means, yes, hydrothermal, where the water in the along the mid-oceanic ridge of the earth, where the plates are separating away in the mid of the ocean, like mid-Atlantic ridge. If it is going away in this hydrothermal vent, this is a geothermal event, you can say. So along the geothermal events, you can be able to say that this is also correct one. Earthquake swarms always result in a major destructive earthquake? No. So only we can say that 1 and 2 is correct. So here it is only 1 and 2 is correct. Got it? So another that we can be able to say, like now if we have to see that earthquake swarms in what I said, that earthquake swarm, we have been understood earthquake swarms in California. So here that this plate is moving in this direction, here it is moving, this is known as a transform boundary. When the two plates are slipping past each other in opposite direction, it is known as a transform boundary. And along that there is a San Andreas fault also, and nearby that there is also Salton Sea in this region. So in California, swarms occur frequently along the active fault system. Which kind of fault we can say that you can say it is in a what transform boundary, you can say also transform boundary. And another that we can say that it is in a strike slip fault, strike slip fault. And when it occur, when the two plates are, I said that moving in what opposite direction, that is in a strike slip fault, or you can say transform boundary. Here it is happening, and nearby this California, this one, there's a Salton Sea is there also. So important areas associated. The question can be also not only with this San Andreas fault, what is the nearby important areas that they can also ask. It is related to Salton Sea, you can be able to see nearby this. So in California, swarms occur frequently along the active fault. Important areas associated are San Andreas Fault and Salton Sea. Reason kya hai? Yes, one is this side is a Pacific plate, another is a North American plate. And Pacific plate, you can say the movement of the Pacific plate and the North American plate. So along that, this kind of movement is taking place. These swarms sometimes precede large earthquake, but often do not lead to major earthquakes. So it can be what I said, that larger means this is a large number of earthquakes, but major earthquake never it occurs. And here we can say that with reference to the earthquake swarm in California, it is a question based on, I said that I have made it is for the California. Consider the following statement: earthquake swarms in the California are often associated with the movement of fluids in the geothermal region. So there is, I said that yes, in this region along that plates transform boundary, fluids are coming, so it is causing lubricancy, and due to the lubricancy, I have discussed that lubricancy causes what small kind of shaking and earthquake. So in this region, this statement geothermal regions are there. Earthquake swarms in California always precede a major earthquake. Not major earthquake को नहीं करता. Major earthquake कभी भी in any swarm major work before and after, there is never. And thereafter we can say such swarms can occur along transform plate boundaries. Yes, this is your transform plate boundary. If it is, I am talking about this earthquake swarm in California, it is occurring along transform, that is a strike slip fault. It is occur along the transform plate boundaries such as the San Andreas Fault. So this statement is correct. 1 and 3 is what you can say correct one is there. And after that we can say like there is an earthquake swarms in Iceland. Iceland, you know that Iceland is the region which is in the mid of the ocean. One side is what the North American plate is moving this side, another side Eurasian plate is moving this side. It is the middle of it, and due to divergence basaltic magmas are keep on coming up, and that it comes above the sea surface, it become an Iceland. So Iceland is the region where it is in a fissure. It is in a kind of also fissure eruption. It is in a diverging and crack in the larger area fissure. And in this region, if I am talking about this way, magmas are separating out. And this is the reason. And Reykjavik is the capital of Iceland. You must be knowing. So here, the Iceland experiences a frequent swarms due to the volcanic and tectonic activity, means divergent tectonic activity, convergent, divergent, it is in a tectonic activity, and during the tectonic activity magmas are also erupting out. Very basaltic magma comes up with the effusion, it is not causing explosion. So here regions are, what are the reason behind it? It is located along the mid-Atlantic ridge. Yes, Iceland is along the mid-Atlantic ridge, the longest mid-oceanic ridge of the world. And here one side North American plate is moving, one side Eurasian plate is moving. So boundary between, it is in a boundary between the Eurasian plate and the North American plate. Important, which one I said that? Iceland, and one Reykjanes Peninsula. This is your Reykjanes Peninsula is there. In this region mostly it occur earthquake swarms. So here we have seen about, I say that earthquake swarm in Iceland, why it is happening. So here we can be able to say that related to that some questions are there. With reference to the earthquake swarm in Iceland, consider the following statements. Earthquake swarms in the Iceland occur only due to transform fault activity. It is wrong. Transform, it is in a, what I said that it is in a California, earthquake in California. In this one, it is by the water tectonic movement, plates are diverging, and there is a volcanic activity is happening, magma, basaltic magma comes up. Earthquake swarms in Iceland are often associated with the magma movement beneath volcanic system. So there is a volcano, there is a Iceland is there, and beneath there is a volcanic activity is taking place, and when it comes up, easily it comes and causing a small earthquake. So this is what we can say correct statement. And thereafter Iceland is located along the mid-Atlantic ridge, where the North American plate and the Eurasian plates are moving apart. So this statement is also correct, means 2 and 3 is correct. So we have seen about, I said that these topics, and we try to complete the 6 topics out of the 100 important topics. In the next video, in the next classes, we'll go with, I said that rest of it, and it will be very much important for this coming prelims 2026. So we will meet in the next video. Till then, keep on enjoying, and if you have any kind of questions, so keep your, I said that, giving comments in the comment box. Till then.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.